All right, so I got an email about some questions from Chapter 2 assignment. It's best if you put them on the discussion thread, but nevertheless, here's my little hints for you. So this is Chapter 2, assignment question 10, and there's an electron. Here's my electron, and it's in some type of electronic tube. And the mass of the electron is given. And when this electron is in this tube, so here's this tube that the electron is in. When it's in here, it experiences this net force right there. So they want us to calculate the acceleration. Well, if you know the mass of the object and you know the net force, you should be able to calculate the acceleration. It's pretty straightforward. B. In B, they're saying this electron that's in this tube, okay, it's in this tube. This electron, let's assume it starts at a velocity equal to 0. What do they want us to find? They want us to find how fast it's moving, or final velocity, after it's moved for 2 centimeters. Well, we don't use centimeters, we use meters. So it's 0.02 meters positive because it's a vector. All right? So if you know the initial velocity, and you know the displacement, and you know the acceleration that you figured out in part A, by knowing all of these three things here, there is a kinematics equation out there that will let you calculate for the final velocity. I'm sure you can find it. All right, I was also asked through email about number 13 in chapter 2. This is a written solution in proper sentences. There's no equation calculations going on here. So this is ice right here in the yellow. It's ice. And right in the middle is a red dot that's a meter across, a meter diameter. And here you are here at the edge. This is your initial position, all right? And you need to start moving. So you got to start moving until you get to the red dot. And then you don't want to keep moving. You want to stop in here. So somehow you have to figure out a way to do this. And in your figuring out how to do this, you have to apply all three of Newton's laws, the first law, the second law, the third law, in explaining how you can get from here to here on this virtually frictionless ice. Be creative, think outside the box, and come up with a way to do that. Hope this helps. Alrighty here. I was also asked about number 16. And number 16 has got 16A, 16B, and 16C. So let's start with 16A. Two teenagers are pushing a dirt bike. Here's the dirt bike. Here's my free body diagram of the dirt bike. There it is. And we're told that there are three forces on it. One teenager is pushing with positive 390 newtons. Oops, let me fix that. Doesn't look like a nice N. There it is. Okay. Another teenager is pushing with 430 newtons, and then there's a force of friction working against it at 810 newtons. I've made west be positive. That's why we got positive values here and negative for the force of friction. All right. So these are the only forces we're really interested in. So use these three to calculate net force and draw a free body diagram. B, we're a water skier and it's being pulled directly by a motorboat. Now, this is the key thing here. It's telling you the velocity is constant. If the velocity is constant, it's telling you the acceleration of 0. If you know the acceleration is 0, you should be able to tell me what F net is. You should be able to tell me what F net is if the acceleration is 0. Now, what's going on with the boat here? Well, it tells us it's being pulled forward by a rope. So there's some type of tension here, and it's positive 520 newtons, positive being forward. And we're also told that it's being pulled in the water. So there'd be some type of frictional force. And those are the main forces acting on it. So you have to draw a free body diagram, taking these forces into consideration, and use this statement up here to tell me what the net force is. C, we're in an elevator. Here's the elevator right there with the passengers in it. There's the beginnings of my free body diagram, and we're told the mass is 1.0 times 10 to the 3 newtons. And we're told that a cable is attached to the elevator. It's going to pull this elevator upward. So here's force cable upward, right? We're saying that up is positive here. That's why I made it positive. And we're told how much is in the cable that's attached to the elevator pulling it up. We're also told that there's the force of friction on it because elevators are moving tracks with wheels and such. So there's going to be some frictional force working against it. And there it is. Friction works against motion. If the elevator is moving upward and upward is positive, friction has to be negative. There it is. But we're on the planet Earth and we're told the mass of the elevator. So you should be able to figure out the force of gravity. So here are the forces acting on it. Draw a free body diagram. You know how to draw a free body diagram. And use that to use these forces to calculate the net force. So thanks so much for asking these questions. I really appreciate it. Bye-bye.